All right, back for Advent of Code day 15. I arrived a little bit late to my computer today, so starting a bit late here, but okay. It's a big grid. What is it asking? Some of all the boxes GPS coordinates. We need to move somewhere, I think. And then the question is, do boxes move on the way is what I'm getting from this? I need to get the input. Okay, there's the input. Oh, interesting. What actually is the, oh, I see, it's two things. Okay, so let's do split here. Okay, and then they're both grids, actually, so I don't actually know. Oh, I see, never mind. Only the first one's a grid. That's S1, and then the second one, I think, is a series of instructions. If there's a box in the way, then it will attempt to push these boxes. If it would cause the robot or box to move in a wall, nothing moves instead, including the robot. Okay. What are O's? Boxes are what? I think these are a sequence of moves, but okay, so for move in S2, what we're gonna do, first we gotta figure out where we start. What are we? We're the @ sign, I think. Okay. Okay, 24 is where we're starting. It seems fine. And then we need to just do the thing, right? For move, the dx dy is going to be, let's see, up is going to be, x is our first coordinate, so up is going to be -1, 0. This means that down is +1, 0. Right is 0, +1. Left is 0, -1. So this of move is our instruction. And then boxes are O's. Okay. And what we're going to do is we're going to try and figure out the robot would move somewhere, and then if the robot would move somewhere, then the box. Okay, so this is going to be cx plus dx, cy plus dy. If either g of nx and y is equal to a wall, then nothing happens. Or we try and figure out all the things that need to move. So I think all the things that need to move are going to be, let's do boxes, and then while g of, well, first, I guess, this is a wall around everything, so we don't need to worry about out-of-bounds checks. While it's a box, then, and I guess we just do this. And then when we're done, we have a list of boxes that need to move. And we also have the final coordinates of the final box. And then now, if this is this, then nothing moves. Else, I guess assert that it's not another box, because we should have found all those. And then what we'll do, maybe just assert that it's empty, I guess. Actually, it sounds better. And then what we'll do is I think we'll just move everything by 1. So we will do for cxcy in, maybe I'll do xy. Let's do p1, x1, y1, x2, y2, and zip. We'll zip the set of things that need to move are cxcy plus the boxes, I think. Everything plus the new location. So if we zip this with itself, oops, let me scroll down. If we zip this with itself, then it is the case that g of x2, y2, oh shoot, we should go backwards. Yeah, let's do this. It's a terrible way to do this, but fine. And then we're going to move. So this becomes this, I think. And then when we're finally done, cxcy should be empty. And then now cxcy is equal to, it's actually just cx plus dx, cy plus dy, not nx, ny, because that's where the boxes moved. And the question is actually something about the boxes that are moving. all the boxes GPS coordinates after they're finished moving. Okay, fine. The GPS coordinates, the coordinates are just the x plus the y, is that right? I should check this before I edit. 100 times its distance from the top edge of the map plus its distance from the left edge of the map. See, good that I read it. For I in range n. If it is a box, then top edge of the map, that's I, plus distance from the left edge of the map, j. Does not stop at wall tiles all the way to the edge of the map. Okay, cool. I think that's our answer then. No! What is S2? Do I accidentally have a new line character in here? No? Huh? Move. For move in S2. Where is this coming from? Oh. The moves are split onto new lines. Broken multiple lines just make copy pasting easier. Ah, come on, man. Okay, fine. Fine. There's an answer. I already copied it. Rank 35. Okay, that's great. Start the map, make the following changes. Oh no, I'm not gonna like this. Okay. It's twice as wide. Okay. So I guess what we'll do. Wait, what are the brackets? With wide boxes. Oh no! I am gonna have to change my code a lot. They can push 2 other boxes at once. Okay. Let's rewrite this a little bit. This is instead going to change to a series of coordinates that need to move at all. So what we'll do, and this needs to be recursive, I think, because you could actually push like exponentially many boxes at once, I think. Let me make sure that, yeah, because you have it kind of set up like this, where 1 splits into 2. Okay, so I think what we're going to do is, yeah, if we... chords to move. Okay, fine. Chords to move. And then we certainly need to move the player character, which is CX, CY. And then also what we're going to do is we're going to repeat the process of for x, y in chords to move. The new coordinate that we'll move it to is x plus dx, y plus dy. And then if this new coordinate is a empty space, we do nothing. If it's a box, then we add it to chords to move. So I think what we'll do, this is kind of like a breadth first search. I actually forget how the iteration order works here, but we will xy chords to move of I. Find this if grid of an x and y is in if either a box or it's one of these things, then we are going to have to move this coordinate as well. If it is a box, if it's one of these guys, so if it's equal to this, then we're also going to have to move this one. And then if it's equal to this one, we also have to move this. Okay, fine. So now we have, and then I plus 1. When we're done, we have a list of all the coordinates to move. And then what we're going to do is we're just going to move every coordinate up by 1. Let's make a new copy of the grid for this, actually. New grid. We'll just do, I don't know. No, we should actually start it off as g of ij for j and I. Okay, and then what we're going to do is for xy in chords to move. We're going to move that chord. So new grid of x plus dx, y plus dy is equal to the old grid of x and y. So that just slides on up. I think this should cover everything. This is effectively doing a breadth first search. We have the new grid, and then G just becomes the new grid. Right? And I think that's fine. It is the case that when we do this, I think we also want to set new grid of x. Yeah, when we move a thing, the old space becomes unoccupied. Does the ordering matter here? I feel like it does. It definitely does. Shoot, how do I actually move things in like the right order? This is kind of terrible. Maybe I do this. First, I delete them all from existence, and then I do another pass, and then I put them where they're meant to be. This is fine. This is actually completely fine. Cool. That should work. Get rid of this. CX needs to update. Oh, right. There's a chance that chords to move cannot move. Oh, is it possible that some boxes can move but not others? I think either everything moves or nothing moves. I'm not confident about this claim. No, I think that's right. So I think if we ever add a if we ever see a wall in a place where a thing has to go, then the entire move is impossible. This starts off with false, and then if impos continue. Okay, cool. Otherwise, everything can move. Everything does move. CX and CY are updated accordingly, and we are good. We need to make the new grid now, I think. Maybe it's... I'm curious to see if the old approach works still. It should. Same answer, hopefully. It's a lot slower. Same answer. Okay, fantastic. That really improves my confidence here. Although, obviously, we didn't test the new kinds of boxes. So let's try the new boxes. It's just a row-wise transformation. So I think what we'll do... then... Oh, all the boxes are bigger now. I didn't realize that. An at becomes a at and a dot. And a dot becomes two dots. Okay, and then g2.pen new pen row, g equals g2, and m len g0. I think this should be fine. Yep, that's fine. The coordinates, I think we just want to find the left edges of the box now. Let's try this. Let's see if I can get PyPy here. I don't know how much faster it'll be. I am certainly allocating a lot of wasted memory here. I could figure out how far I am along the process. I don't know if that'll be useful at all. I guess I can. There's no way. Oh, wait, I have a while loop. That's not great. I'm worried about me having infinite loops. So I think I actually do want to do this at least. Run it here. Enumerate. I hope the instructions didn't get longer. If the instructions got longer, I'll be sad. Oh dear, where are we stuck? xy equals c2m. We're stuck here? How are we stuck here? Impos true, break. I should always be increasing. We have duplicates in here? We have duplicates in here, and that's pretty bad. Oh, right, because I'm going through everything again. Okay, shoot. Yeah, this is a terribly inefficient loop. Let's do... Oof. This is so bad. Okay, that looks good. It's going faster now, so let's try that. Faster. How many instructions are there? 20,000. Okay. Can I kill my PyPy, please? Okay, apparently not. Oh, there's an answer? That seems suspiciously similar. Rank 2! Oh my god! Yes! Oh, man. Oh, that was fantastic. Yeah, so I didn't get a chance to explain at the beginning, but I was pretty late coming back from something else. So I was like rushing to get to my computer. I actually ran here from the train station. And that's why I'm a little bit out of breath right now. Okay, this finally got my keyboard interrupt. Oh yeah, that's how fast PyPy was. Oh man, how close was I from rank 1? I'm actually really curious. Oh no, I was 3 seconds off of rank 1. Oh, that's so sad. Oh wow, we're all flooding in at the same time. That's pretty funny. Oh man, that is so sad. If my PyPy had responded to my keyboard interrupt, that might have been enough. Oh, okay, but still, that was a fantastic showing for today. It would have been nice to have another first place. I think I've only ever gotten one first place before, and it was on a part 1 in 2022, I think. But I'm not sure off the top of my head. I guess I could check. Yeah, it was this one. And then I choked the part 2 on that day, so that's fun. But yeah, anyways, this is still a great score for one day. Rank 35 in rank 2, that's crazy. That probably takes me up a decent distance on the global. Yeah, it does. Up to 53rd. Oh man, I guess part 1. I was surprised I got such a high score on part 1. I guess like clearly some LLMs can solve it. Probably a lot of these are too actually. How fast was I? 6 minutes. Yeah, it was pretty involved, but anyways, it's clearly doable by some. But I'm guessing you either had to have a good prompt, or maybe you had to get lucky, or you like have some sophisticated-ish LLM setup. So that's why there's not a lot of them. I'm not really sure. But I was very surprised to see such a high rank for a part 1. I was like, oh, well, I didn't know how long it was at the time, but it felt like a decent amount of time. And like a 6-minute time making top 100 has to be a day when the LLMs just like are not having a great showing. But yeah, rank 2 is crazy. That's great. Oh man, I'm so happy about that. Whoa, it's filling up so slowly too. I guess there is like a lot of complicated stuff to do here. I had to rewrite like my first part, unfortunately. If I didn't have to rewrite my first part, that might have been a good bit faster. But yeah, cool. So I guess I can talk about the question now. It's not a terribly algorithmic day. It is mostly a implement a thing day. But I guess there was one gotcha in part 2. So the problem statement is basically we're given this grid, and it is a warehouse. Dots are empty, pound signs are walls, at is us, and then O is boxes. And it gives us some sequence of instructions, which are movements like left, down, right, up, left, and so on. And it says like, do these movements. If you do the movement and you try and push a box, or you run into a box, then you push that box. And this is also true of like the box can push another box. So you can push as many boxes as you want all at once. And it says like, do all these moves. You like do some stuff in the warehouse, and the boxes will end up in some positions. And then do some computation on like where the boxes end up. Like sum up 100 times their x coordinate plus their y coordinate, where y is measured from the top. Or sorry, 100 times their y coordinate and then plus their x coordinate. But yeah, and this one I think you mostly just do. Like it's a little bit of annoying implementation, but there's nothing too tricky going on here, I think. The way that I did it was I took a step in this direction. I checked the direction that we want to go. If it's a box, then I append it to a list, and I keep going that direction. And I keep going until I either see a empty space or a wall. If I see an empty space, then great, everything can move. If I see a wall, then nothing can move, and we just like skip this step. If we see an empty space, then we need to move everything. And one tricky bit is like, if you only have one grid, moving everything could be a little bit annoying. You really want to make sure you go in like backwards order, and you move the last one first, then you move this one, and then you move that one, and so on. You could go from like front to the end, but then you need to write some ugly logic about assert that the first thing gets replaced with like an empty dot. It's maybe not too bad, but I just found it easier to go backwards when I do these moves. And that was basically just what I wrote here. And that is part one. Part two says, okay, now like do this manipulation. The warehouse actually looks like this, and boxes are now like twice as wide. And because of this, it can be the case that pushing one box could result in I'm trying to figure out how to word it best, but one box could push not just one more box, but it could push two more boxes simultaneously. So if you were, this example is actually great. If you're underneath this formation of boxes and you go up, pushing up on this one will push up both of these boxes because they're 2 by 1. It says now do the same process, and again, like do the computation. The trick here, so I rewrote my code for this basically. The new thing that I did was I decided to just come up with a complete list of coordinates to move. And once I had this list of coordinates to move, and I decided to move them, then I could just like move everything all at once. And rather than go like backwards, because now it's like a little bit annoying to go in the correct order because you can't just like go in reverse order. The order you've added these boxes in, maybe it's fine. Maybe you can just go in reverse order, but I wasn't confident about that. So I actually just copied a new grid. And if you keep 2 different grids lying around, it's not too bad. You can like empty out everything in the grid first, then you can do all the moves by reading the old grid to decide what was there. That's the reason why the ordering mattered in the first approach. You don't want to accidentally overwrite something with like an empty space before it actually moves. So having 2 buffers for this just like makes life easier. But yeah, and then figuring out the chords to move. I wrote this kind of like a breadth first search. It's like the only reason I say it's kind of like a breadth first search is because I've seen competitive programmers write breadth first searches this way before, which is like a little deranged, but C2M is like kind of your scene set, and you like keep a pointer into this thing and you move it forward as you add stuff, you append stuff to the end of the list. So normally in a breadth first search, you keep like a queue, and you pop from the front and you add to the back. And the idea here is that this is kind of implicitly a queue, but we're moving the start pointer forwards rather than explicitly popping from the front of the queue. This lets you use like a regular list instead of having to use an actual queue, which has like bad constants. It's also nice because it quickly gives you the entire scene set, which is something I kind of wanted here. So yeah, you can kind of see it that way. I don't know if I'd really call it a breadth first search explicitly, but it resembles that. And the logic here is basically, so C2M is short for chords to move. So for every coordinate that wants to move, the first one that wants to move is just us. We're going to check where it would move to. If the thing it would move to is a box, then that too must move, so it gets added to chords to move. And if it's the left half of a box, we also add the right half of the box to the chords to move. If it's the right half of the box, we also add the left half. And then the idea is that then that will try to move, and we'll do another check, like when we enter this loop again. And we make sure that like every coordinate that wants to move will end up getting checked, and its like dependencies in some sense, the things that will push, will also get in-queued as things to move. And if at any point we see a pound sign, that indicates that the entire move is impossible. This fact actually took me a second to convince myself of, but I think it's not too hard to think about if you think carefully. Like in this example here, or maybe I'll take this one. Oh yeah, they actually have an example here too. That's great. Great example today. So we're at this location and we want to move up. And if we try moving up, like pushing on this will push on this, which gets stopped here. And we can't move this up. Like even though this box could move up, we can't move this box up without also moving this one up. So it's just not possible. Any way you can draw these like boxes and some dependency, there's no way to like move the starting guy and move some of the boxes, but not all of them. Or all of the ones that are like dependent boxes here. So yeah, if at any point we ever see a wall, then the move is just impossible. We break and then we skip the next step. And that was basically what I wrote. I just yeah, I wrote it pretty cleanly and quickly. I had one bug question mark with this. I'm still not actually sure why I needed this check. It seemed like I was adding a bunch of duplicate elements to my list, and I'm not really sure why. Oh, that's why. Yeah, okay. It's specifically because of this. What was happening was if I have a location like this, and I want to move up, I would enqueue this one into my stack. My stack would consist of, this is going to look terrible, but it consists of this at first. Then I would go like, oh, he wants to move, let's do this. He wants to move up, so this also has to move. So it would enqueue this. And then in order for this to move, it would have to enqueue this. You have to assume that this is the correct empty dot. I'm not going to label it with coordinates. And also, because it's the right half of the box, the left half would have to move as well. So it would also enqueue this. But then when we got to the left half of the box, this one's fine. This we can move into here, so it's fine. When we get to the left half of the box, we would also enqueue the right half of the box. And this process would infinitely loop back and forth. So we would just end up in an infinite loop here. And the solution to this, I didn't realize fully at the time why I needed this, because I didn't realize this until just now. But I did notice the symptom, which is that I had a bunch of duplicate locations appearing here. And the fix was just to not add coordinates and just chords to move if they're already there. And this check is pretty inefficient because this is a list. It would have been better to keep a C2M set, which is a set of C2M. And then whenever you append, you also add it to the set. Maybe, I forget if sets in Python are ordered or not. I know dictionaries are, but I seem to recall sets are maybe not, or maybe implementation dependent. So I generally wouldn't rely on that, but you could track a set of some kind, either in addition to or instead of if they do happen to be ordered sets. Yeah, and then that would be a lot faster to check if it's in the set or not. But yeah, it turns out this was fast enough. Like usual in Advent of Code, speed of writing the code is much more important than speed of running the code, except for a few cases. So yeah, I think that's all there is to day 15. And let's see, is the leaderboard full now? Wow, it's still only half full. This is a slow day for a lot of people. Yeah, I mean, it definitely is a pretty involved problem. I'm maybe a little surprised that it's taking this long for things to fill up. But I guess to be fair, a lot of the time I'm on the other end of the tail here, where I am taking a very long time, and I'm like, how do people solve that in 15 minutes? So I can't really complain too much, or not complain. I'm not complaining. I'm very happy I got second, but I can't speculate too much about why it's taking a while here for leaderboard to fill. But yeah, this is a fun problem. Obviously, I find it more fun when I do better. Yeah, I think that is all I have for day 15 of Advent of Code. And I will see you tomorrow. Yeah.